Hello, everyone. This week we're going to be looking at wind resources in your state, and if your state could indeed or has enough wind resources to power it, or at least a percentage of it. And what I mean by that is if you come to a website called thesolutionsproject.org, it's a team at Stanford University looked at what renewable resources each state has, and if they were going to move towards a 100% renewable economy, what resources might they most rely on, and what resources, essentially what the fuel mix would end up being. And this was actually the primary research behind Bernie Sanders' vision for this is the research that he campaigned on. This map was actually integrated into his website. But if you go click on each one of these states, they can give you a sense for. So they're thinking in Ohio that Ohio has pretty good wind resources, and that I could probably generate 55%, or it would make sense to generate 55% from wind. If we go out to a place like Kansas, they have even better wind resources, and they're going to be generating a lot from wind. So this is a really good starting place to give you a sense for if you were to transition, how much of that, the number that we generated last week, mine was around 25 gigawatts. What percentage of that number? So they're saying that 55% for me is generated by wind. And I have to back up a little bit. So if we do the math, that's maybe around 13 gigawatts that I have to generate from wind. The next thing you should do is you should go to the Department of Energy, but more specifically the Office of Energy Efficiency and Renewable Energy. Scroll down and click into wind. And this is going to take us to a lot of really good information about wind in the United States and wind resources in the United States. Click on Wind Exchange, and this is going to give us a lot of really good data. Okay, so these maps have been developed in large part by the National Renewable Energy Laboratories. National Renewable Energy Laboratories is basically like NASA for renewable energy. It's funded by the US government and does a lot of really good research. So we're going to be interested in two maps. We're going to be interested in the wind capacity, on-land wind capacity potential, and we're going to be interested in the offshore wind potential. So let's click into one of these. From there, we can click, this will give you a national overview, but if you're more interested in your state, then you can click into your state. I'll do California because it has offshore and has a lot of offshore and on land resources. This is going to give you a couple very detailed maps on your state and where the best wind resources are. And you can also access this table, Excel table, that will, I think we talked about this in class, but it'll tell you about the total area in your state, total kilometers, that are at a 35% capacity factor. And what capacity factor means, I talked about it a bit in class, but it's really important to understand. It means that if you have a wind turbine that's rated at 2 megawatts, 35% of the time it's going to be operating at maximum capacity. And in the real world, this is probably going to be like 50% of the time it's operating at 60% capacity or 70% capacity. So very rarely are the wind turbines ever going to produce their whole capacity, but a certain percentage of the time they won't be operating, and a certain percentage of the time they will be operating at maybe 50% capacity. So the capacity factor is very important to understand. The other thing that's important to understand on this is if you develop all of the wind resources, in the state. If you were to just max it all out and develop every single bit of it, this is, conceivably what you could get at. So on land, they're talking about 105 gigawatts of energy. Right now, the United States is only drawing 400 or 500 gigawatts, and that would be a huge amount of electricity. One thing to keep in mind here is that what they're referring to here is capacity. So they're talking about there's 105 gigawatts of capacity, but that capacity is only going to be operating maybe 30 or 35% of the time. So the real number here is probably more like 30 gigawatts. We also want to look at the offshore wind resources. So that's going to be this map. And you can go into here, and let's do California again because, like I said, it has a lot of offshore. And you're going to be interested in downloading this report. This is going to tell you how much you can get from each area. So these are the wind speeds at 90 meters of hub height. That means the wind turbines are going to be 90 meters tall. And at 7 to 7.5 meters a second, it's looking like California has about 11,000 square kilometers. And if you come over here to the total of all the different wind resources above 7 meters a second, you can see that just offshore you can be generating 117 gigawatts. Or actually, never mind. That's going to be this number. So because this is square kilometers here and megawatts here. So it's saying you could generate 587 gigawatts, which is, that's the same amount as the entire United States. So that's a big number. If I go down here to Ohio, the total amount is, again, around over 40 gigawatts. So that would certainly cover my state. And then from there, we want to look at, okay, if we're going to be putting in wind farms, where do we want them to go? And one of the best tools that I have found for looking at some of those questions, go to maps.nrel.gov. That's National Renewable Energy Laboratories. NREL is kind of like the NASA of renewable energy. They do a lot of research and are a very good resource. Go scroll down and go to the wind prospector. We looked at this in class. And this is just going to start to, you can manipulate this map, but it's going to be showing the primary wind resources in the state. We're interested in wind resources power class exclusions applied. So this means it's going to take out urban areas, national parks, everywhere you don't want to put turbines, it's going to exclude. And then we can come in here and we can start to look at, we did this in class, but where exactly the wind resources are. I'm going to turn down this. And if we go back, then we can click on Wind Toolkit. And this is a whole bunch of data illustrating, it's kind of hard to see, so I'm going to jump back in here and turn down the actual wind resources. But this is going to give us a whole bunch of data points on places where they have measured the wind and places where they think the estimated capacity factor is. So if we click on one of these dots and we go to Wind Toolkit, it's going to say that the capacity factor for this wind site in Ohio is going to be around 45. So what that means is probably, if we're being conservative, maybe 38 to 40% of the time this wind turbine is going to be operating at maximum capacity. So what you're looking for here is high capacity factors. And those are going to be the best places to put wind turbines, because essentially you're going to be generating more electricity. And after this, you're just going to take a look at some areas. Then you're going to research a wind site that is currently being built in your state. And just let me know if you think it's a good place to put a wind farm, or if they did a good job siting that wind farm.